Welcome to the Unity Engine roadmap, where we're at and where we're going to be going. There are two big areas. We're going to talk about what's next for Unity 6 and what comes after that, or the next generation, if you will.
So kicking off with Unity 6, building the best version of Unity. If you just came from the keynote, you'll know that Unity 6 allows you to create more optimal games on more platforms. Unity 6 comes with faster rendering from GPU resident draw. There's lots of neat quality of life enhancements for productivity across the board, like this asset bundle defaults option. We have deeper support for mobile web runtimes. This is super impactful if you're working on mobile and have people play your games in the browser. And there are expanded AI capabilities with Muse and Sentis. Here in our Time Ghost demo, we used Sentis to enable realistic cloth deformation at runtime with machine learning model that we trained ourselves. And with Muse, we're enhancing workflows through deeper AI integration into the editor. Two examples, so this context-aware chat that understands the context and the content of your project and can even carry out instructions for you. So here we're asking it to add gravity to this boulder, and of course it adds a rigid body. So a very simple example, but there's lots more to come. And there's 2D enhancers, like this sprite upscaler that you can up-res your sprites basically right inside the sprite importer. Super helpful. And there's powerful lighting with adaptive probe volumes, and of course, end-to-end multiplayer workflows.
First, the time between generations, those major versions, will be longer, generally a minimum of 2 years. So with this long dev cycle, and this is the key part, it really gives us more time to evolve Unity and adapt based on what we hear from you and your feedback. Quick note on patch releases. So these, as I mentioned, work just like they do with the LTS for Unity 6. We really love, right? Now, back to update releases. These are the new things. We do pack port between generations, but not within them. The first update release will be 6.1, as you heard earlier, and it will enter beta in January and ship in April of next year. The cycle then repeats itself through the generation, and we'll be documenting a lot more about this on our blog. I promise it's going to get better from here, Will. So let's talk about what's coming next to the Unity 6 generation. The focus of this first update release, and in fact all update releases for Unity 6, is going to be about quality, performance, platform updates, as well as additive features, things that you can opt into, feature enhancements, and so on. First up is graphics. So MeshLOD, it's our new lightweight LOD system that's complementary to LOD groups. Inspector here, and basically enable MeshLOD in the importer. A MeshLOD places the LODs in the meshes. You can then preview those on each mesh individually if you wish. MeshLOD works on static meshes as well as on skin meshes. Each LOD, of course, trying to keep the best visual quality possible while reducing the number of triangles. With a scene like this, MeshLOD allows us to go from 81 million tries down to 4.5 million. It uses advanced cluster-based light culling. That really accelerates your overall GPU performance and simple threads. And then, specifically for mobile, on-tile deferred rendering brings improvements to mobile devices.
Next up is platforms, recommended packages, and even sub-profiles. So when we know that you're working with a particular platform, we can deliver a great set of default profiles and settings all in a single click. This is another big one. We're improving support for large screens and foldables. For XR, we're making it easier than ever to work more efficiently with improved scene setup by introducing a series of common XR functionality that you can easily add and then customize during production. We think this is going to save you significant time and effort working in XR projects. For mixed reality, we'll be sharing a new tabletop game example that demonstrates how to build multiplayer experiences in mixed reality. Choice of render pipeline is something that you need to choose up front today. URP is still the best choice for mobile, XR, and cross-platform, with HDRP for high-definition stuff across PC and console. But you know what? One of Unity's core tenets was always to help you author once and deploy anywhere. So making you choose and compromise is the opposite of that. So yeah, choices are hard. What if we could remove that decision? Well, spoilers, that's exactly what we're going to do. In our next generation, we are unifying rendering. Yep. Pause for applause. Oh, that's the stage direction, sorry. First things first, before we get too excited, we'll be removing the former built-in renderer in our next generation, this is a roller coaster, isn't it? Will be marking built-in as deprecated during the Unity 6 generation, but it will continue to be supported throughout that generation, for years to come. We know that this is going to have a large impact on many of you. Our recommendation is to migrate your work or familiarize yourself with SRP in your 6th generation projects. So plenty of time to do that. And you can also check out Mathieu is doing a talk on migrating to URP at the Unite event today, or if you're watching this on the stream, check it out on our YouTube channel. So in our next generation, we're going to move to a scalable, unified rendering strategy that will help you take full advantage of the hardware that your game runs on. Unified rendering means that we are not creating yet another solution, but refactoring the URP and HDRP backends to allow us to separate data and logic and give you a completely unified authoring experience. So lights, cameras, materials, and effects will be authored once. That's your data. Then we'll enable you to configure the rendering logic to scale across all of the platforms of your choice. And when unifying, we're really taking the best of the things that we made for URP and HDRP and making them available to you in a unified way. You'll be able to, so for example, you'll be able to author with either physical light units like you do in HDRP or luminance values like you do in URP. You'll be able to customize rendering with the render graph just like you do in URP today. So really, we're cherry-picking the best tooling that we've made for these render pipelines the last few years. And that means if you're already used to some of the conventions of SRP, you'll be prepared for that next generation. And when unifying, we're also standardizing. The new unified lit shader is based on the Open PBR standard hosted by the Academy Software Foundation. This means you can author in a standardized way between Unity and your art package of choice. That means that, again, with one set of content, you'll be able to scale across all possible hardware configurations, everything from the low-end device with simplified lighting all the way up to the most capable device with the highest fidelity. And because iteration time is important, we plan to make testing multiple render configurations as simple as switching between them in a drop-down menu in the editor. In this early video, we're showing multiple different render loops being toggled by the artist as they debugged how the lighting is going to look across their entire hardware range. The render graph here is just showing you those different passes that each loop is executing so that you know it's real. OK, that's not all for graphics. Obviously, you want a bit more graphics, right? To continue simplifying the experience around art in Unity, we're working on Shader Graph 2 and block shaders in order to solve a couple of specific challenges. First, authoring shaders in code and in Shader Graph was inherently different. And shader authoring that we had wasn't really portable enough to meet the aspirations of our unified rendering goal. In our next generation, we're introducing a new generation of node-based tools for technical artists, and of course, enabling those of you, many of you are here in the audience, who like to code their shaders as well. Shader Graph 2 is a complete rebuild of our node-based shader editor. It's built on top of our new Graph API. It includes over 20 new nodes, expanded functionality in more than 50 existing nodes, and the ability to create your own nodes using block shader code. There's major UI improvements like these wire portals that you're seeing here. There's better grid snapping, updated node groups, and a more powerful node searcher as well. So you've got things like these groups, which you'll have seen before. And then if you check out the node searcher, you'll see that there's lots of examples built into it, which is really, really cool. Here you can see a wet weather shader, and you can just drop those nodes in. Super cool. Shader Graph 2 shares a common representation of shaders to our new block shader format. You can author blocks that are used from within the graph or from within a surface shader. So whether you're writing shaders for Shader Graph 2 or in code, you'll have the exact same outcome and performance. It's really important. And we think that this creates a common understanding of shaders for programmers and for artists, and we really think you're going to love it. OK, so let's recap simplicity. We have a single unified renderer. Yay. This means authoring assets once for complete cross-platform reach. We're unifying shading with OpenPBR parameterization, meaning you'll be working with an industry standard. And we're making shader authoring far better, whether you're an artist using nodes or a coder using codes. That's the thing that people say. So that's a wrap on simplicity. But of course, you're going to hear more about this theme and the other two themes as time goes on. Andrew, back to you. What on earth are we going to do about iteration time?
Something about progress bars, I think.
Something about progress bars.
Rid of them entirely, hopefully. So, right, what is it? This is all about building a faster and more productive experience, keeping you as much as possible in that state of creative flow. So we hear consistently from you that iteration time is a huge thing to solve in Unity. And we've identified many areas and metrics where we can improve this for you. For example, things like loading a project and entering play mode, importing assets, updating code, editing prefabs, switching platforms, just building. There are lots of little weights that just add up all over the day. So to achieve this, we're going to be re-architecting key parts of Unity in a way that we have not done before. And that's essential to really solve those needs that you have and set you up for success for years to come. So today, we're going to talk about two main areas of re-architecture, our scripting backend and our content pipeline. So as you know, our team has been hard at work on bringing the latest .NET technology to Unity. So when you're working on your game code, of course, we want you to spend time iterating and not time waiting for your code to load. So we're introducing several improvements in scripting to maximize that productivity. First, with the move to Core CLR, we're replacing the former mono .NET solution with Core CLR. Core CLR is, of course, Microsoft's latest and greatest VM for C#, meaning that you can be always at the cutting edge of performance. And with this Core CLR work, it means that we can stay and always adopt the latest versions of .NET as Microsoft releases them, as is indicated here. And we're going to see out of the box two major benefits there. First, just improved performance of the editor full stop, and of course, improvement of your code, performance of your code at runtime. And we're already seeing inside, certainly internally, a lot of really great improvements for editor responsiveness overall since we've made these changes. But there's also good news for iteration time too, so let's come back to that. So one big change with Core CLR that directly impacts iteration time is the move away from domain reload to assembly load contexts, or ALCs. Today, with domain reload, as you know, all assemblies are reloaded every time. And you can see, of course, that's just a one-to-one. Assembly load context is a flexible way to manage loading and resolving assemblies at runtime. And you have custom ALCs then that basically enable us to dynamically load and unload specific assemblies. So here, quick visual of what that means. So only code that changes is reloaded instead, of course, the whole domain. And that's what brings you back that rapid iteration. And here, of course, you see Unity's core libraries. They don't really change much at all, so they're not part of that. Your studio-specific libraries would be in this long-living ALC, which also rarely changes. And your gameplay code, of course, then sits in the user code ALC. And that's the only thing that gets reloaded, saving a whole lot of time. And if, like Will, you can prepare already for this change by using this Enter Play Mode option. Have you been using this, Will?
I have.
Good. So top marks, Will, and top marks,
much.
all of you have had this selected. We've had this in the engine for a little while to prepare for this change. Right. So another big win for us is this move away from, the introduction of the .NET 8 base class library. So this brings new capabilities like hardware intrinsics and math generics that basically just enables you to write that much more efficient and performant code. This is just an example of an integer search function that someone had done exactly that. And then, of course, for easier memory management and smoother gameplay, we're going to be introducing Core CLR's new high-performance garbage collection. And lastly, we're going to be integrating MS Build. So that's the industry standard build system, and it really brings better IDE integration. And with it, a lot of improvements to debugging between native and managed code. So in this video, you can see how this person's basically going to start jumping between C# and C++ in the same session. They attach the process, and in a moment, they're going to start to hop between those methods in their call stack. I mean, this is just a huge improvement in productivity right here, really just letting you really quickly troubleshoot and fix bugs. It's all about keeping you in that state of flow, keeping interruptions to a minimum. So with that, let's talk about another big change we're making, this time to our content pipeline. So just as important as for reducing iteration is how we work with your content. So Unity's content pipeline, that's what manages basically the life cycle of content from import all the way through to the point it is loaded in your game on device. And today, we're going to share one of the changes we're making to Unity's content pipeline, how and when content is imported. So our goal, as mentioned, is to always keep you in that continuous state of flow. Instead of being interrupted, we want you to iterate more and just focus on making the best possible game. And we'll do this in 3 ways. So by importing less, by importing faster, and importing without blocking the editor. So here's the context. Importing and re-importing content is something that happens throughout your workflow for various reasons in Unity today. So in addition to adding new models and textures and audio files and so on to your project, importing happens in a number of different scenarios. These are the same ones I mentioned earlier. And many of these imports are the things that result in those blocking progress bars, which causes interruptions to your workflow. Another way, as your project, for example, grows in size and structure, importing also affects you in other ways here. For example, like this nested prefab as you're editing. So if you're editing, say, this little leaf here in this large nested tree, which is in turn part of your scene, when you hit save, you have to wait, right? And the reason why this gets slow is because every time a prefab is saved, all the assets that contain this particular prefab must be re-imported. And to do that re-importing, Unity needs to load all those objects back into memory, save them back to disk, and so on. So to tackle this, we're making it so that only the necessary content needs to be re-imported. And to support that, we're introducing a new schema-based data model, which is far more performant and just brings you that much smoother experience. And it's a good example of one of those underlying architectural changes that we talked about earlier. Another good example of how we're removing blocking operations. So with the work we're doing in this next generation version, the importer will prioritize the content you open and use background importing for the rest. So this just enables you to get to work far more quickly. So as you can imagine, this means loading meshes, materials, shaders, textures, and so on progressively. It's about giving you that control as soon as possible. It means far fewer blocking progress bars and interruptions to your flow. And if you just think about the time it usually takes you to be productive in the editor after you get the latest changes, with this background import process, that time is really going to be reduced to a fraction of what it is today. It's big stuff. So let's recap iteration then. So our goal is about bringing you a faster editor iteration speed. Our move to Core CLR brings iteration speed and editor performance, and we shared just some of the changes here that we're making to our content pipeline to keep you in that flow, move things to the background. Whew, that's a lot of pretty powerful stuff there, Will. Yep. Maybe would you like to take us on with something about power?
Okay, sure. So speaking of which, like Andrew said, we call this next theme power because it looks dramatic on a slide. That's the main reason. But also because it's something that we actually believe in. So let's get on with it. So what we're sharing with you today is a major milestone in our work on DOTS, our data-oriented technology stack. You'll learn how a key part of that stack, Entity Component System, or ECS, is going to give you power to your daily game object workflow, as well as 2 advanced new features. We call this ECS for all. The key part of DOTS that enabled you to unlock and deliver ambitious projects was, of course, ECS in combination with things like the job system and the burst compiler. It's the tech that brought you amazing scale, like you saw in these demos, so everything from our own demos to things like Spell Souls from Nordeus, Mega City, and then, of course, amazing games like Hostile Mars from Big Root Games, with its epic amount of enemies, and, of course, who could forget V-Rising from Stunlock Studios as well, with its hundreds of thousands of interactable objects. Super, super cool. So while ECS is incredibly advanced, many users have yet to take full advantage of it. And we want to bring this capability to a wider audience. In other words, all of you. So that's why we're building ECS into the core of Unity, such that every game object is backed by an entity. That means that everything you need is in the core of Unity with far fewer steps to adopt the power of ECS. Writing game code using the ECS paradigm will be as simple as writing systems and components and adding them to your game objects. As a reminder of why this is so important, just keep in mind that game object data today is kind of scattered around individual allocations throughout memory. And so you're inefficiently traversing lots of different addresses. With ECS, your memory allocations are always laid out side by side in a kind of neat way in memory. And so it's way more efficient to use because of that. And another part of ECS that we're evolving is with the transform. So this is a common bottleneck for the performance of even ECS that we find today. This is because we spend a lot of time reading, writing, synchronizing between the transform representation of a game object and of an entity. And that can really eat into the performance. So this is no longer going to be so with unified transform. Unified transform is going to consolidate the ECS and game object transforms, so we no longer have to do that copying of data between the two representations. Another benefit this is going to give us is that we can now have mixed hierarchies that contain both game objects and entities, something that was impossible to do before. We'll now be able to have game object parents with entity children and vice versa. Parents, you should never refer to your children as entities. Anyway, and what segment on ECS would be complete without a demo flex on scale? So here's our most recent Galaxy demo, in which we're showing between 120 and 500,000 entities, all running at a minimum of 30 FPS. And what's more exciting is that we're developing a whole host of features on top of this ECS for all foundation. And this is going to allow you to reap significant benefits even if you don't use the ECS paradigm directly. In fact, two of those features are a new animation system and a new world-building system. So let's not just stare into space, let's take a look at them. So let's start with the new animation system. Whatever your team size, Unity's new animation system will easily take on the most outrageous animation challenges for many years to come. It's designed for gameplay programmers and technical animators to build flexible and scalable pipelines. Let's have a look at some highlights. We'll start with a really big change. You'll see that everywhere in the new system, in just one click, you can preview everything without having to load it into the scene first. Pretty important. This is going to reduce a lot of frustration and human error, as it only will show you the compatible clips with the character you have selected. Our new skeleton workflow allows you to go beyond what's in your imported rig. You'll simply be able to add, edit, and reset your required or default pose, or if you prefer, simply disable bones that you don't need. And all of the changes that we have there, they're stored locally. So making any updates from the art package is way less fragile and far less painful than before. There's a new socket object as well, which is used as a kind of a virtual transform. And this means that it no longer has to be a fragile bone that you create inside your art package, which could get nudged and so on. So here you can see that we're previewing attachments along with their animations. The great thing is that you can edit and preview the socket, and then you can make sure that the position and the orientation of everything is exactly correct for all the animations you're going to apply to it. And this is going to reduce error for, obviously, things like weapon placement that we're showing here. There'll no longer be a commitment up front when importing, as you'll be able to preview everything, edit your clip, and add custom properties. You'll be able to create and edit animation events, and even use multiple tracks, and use range markup as well. The all-new remapping system means that anything is possible. So here are two characters that are going to use the same animation. So you're going to be able to remap anything to anything, independent of naming, the hierarchy, or, of course, in this example, the proportions. And it will work offline and at runtime. So you can see as we apply here, that animation is just working for both characters. Graphs are at the center of everything in the new system. They're designed to give technical animators more creative freedom for their gameplay implementation without having to code. Graphs are approachable, yet extensible, and reduce the bottleneck on programming. They are built on a new graph stack, just like Shader Graph 2, and can be packaged and reused. You could use runtime rigging for any character type, or indeed create your own nodes with your own special source. The all-new state machine is truly hierarchical, designed to scale even if you have thousands of animation sources. It's highly optimized, much easier to read, refactor, and reused with layers, blend spaces, subgraphs, integrated rig graphs, as well as constraints and math operations as well. You'll be able to easily swap animation while keeping your orchestration logic intact. So it not only offers you a serious level of control over your animation, but incredible performance at scale as well. I love this next feature. So we're working on live visual graph debugging with in-game recording and gameplay. So this makes it easy to navigate to the source of any particular animation problem that you've got, no matter how complex the setup. You can simply record and then rewind the game data frame by frame and see what's going on in the graph at any particular moment. Not only does this mean that you're going to ship fewer in-game animation bugs, but it means you can afford to make some changes later in production because we're effectively de-risking. The new animation system is, of course, built with performance in mind. It's built on ECS and, of course, therefore works with game objects too. It's written in C# and high-performance C#, and all animation code is running burst compatible, meaning you have performance, kind of native execution. You'll have control over the execution order, customizable phases, and all callbacks will be deferred. We've also removed some of the former limitations, like, for example, the sync point bottleneck, the overhead when rebinding animations at runtime. And what you're seeing here is a demo of 1,000 nights running on this new system, all at a steady 30 FPS inside the editor. Really, this is just the beginning. So, Andrew, what hero character would be complete without a world to explore? Let's talk about world building. Unity's new world-building system is powered by entities and built with the future of game development in mind. These new tools are designed primarily for technical artists choosing this Unity to build bigger, more ambitious games. Our goal is to offer much more flexibility during iteration, later in production, and the foundational tech is there to unlock unprecedented performance at scale across all of Unity's supported platforms. Let's have a look at some highlights. Once in the editor, you can establish masks and procedural rule sets based on altitude, curvature, and slope. And that offers non-destructive editing, super important, and adaptation during your edits. Ultimately, we want to give you more flexibility throughout production when you find changes that you want to make. Really cool. And here you can see how we grab this piece of an island, duplicate it, drag it across, and it's all of those procedural rule sets just kick in and make it work perfectly. Here you can see how we integrate shader graph into the terrain surface and enable blending of meshes far more seamlessly. So this is one of those kind of long-standing feature requests, and I think it looks pretty nice. And here we have an example of how you can integrate hero assets in and have all of your rules, materials, scattered assets, and masks respond to your placement. So this basically means you can spend more time finding the perfect layout of the level without having to worry and rework everything if you change your mind. Absolutely love this thing. It's great. So for performance as well, there's virtual texturing and tessellation, and they provide more detail in the world close to the player where they can see it the most, and it automatically reduces complexity away from the camera to optimize performance. And here we can see how the system is quickly setting up procedurally scattered objects like speed trees. Remember, this is using entities under the hood. So we enable density up close and then scale in the background, which makes the best use of the capabilities of the target hardware device. And all of this equates to performance at scale for your most ambitious endeavors. And of course, it wouldn't make sense for us to release tools like this only on high-end platforms. So we want to offer you the flexibility to choose the right platforms for your creations, no matter what your ambition. Whether you're targeting mobile, PC, console, XR, we want to give you stunning graphics and performance. Let's recap power, Andrew. So we have ECS for all, built into the core of Unity, powering game objects and unlocking big performance boosts for everybody. We have new features coming built on this foundation, a new animation system, and a new world-building system. And these target flexibility, scale, and platform reach. So Andrew, lots of exciting stuff coming in development. Some of it a ways off. Back to you to wrap things up.
Thank you, Will. So coming back to the goal for our next generation, it's to ensure that you have a future-proof engine. It's been really exciting to share what we have in store for you. And we want to share early, and we want your feedback. We want to make sure that we're really hitting the mark with the next generation. And a huge shout out to the engineering teams that have been working hard to bring you Unity 6 and bring you what's next and all the great updates that we've shared today. They're also all ready and eager to listen to your feedback. So that is a wrap, everybody. We started with the Unity 6 generation, and we talked about how we'll release Unity to you with our new generational model. We shared some of the highlights coming as part of that Unity 6 generation. Unity 6 is going to be available on October 17th in GA, and the first update arriving April next year. And then we gave you insight on where we're going to take Unity next. And we talked about how we're going to unify our solution, making it simpler to make the right choice, and how we're going to be relentless in returning iteration speed and productivity to your editor experience. And lastly, bringing powerful, performant tools and runtime to play. You can download the Unity 6 preview right in the hub, and come join us on Unity discussions. So we're going to be hosting dedicated threads with our teams at the ready to hear your feedback on what we shared today or in this video if you're watching it on YouTube. So thank you for all of your attention today. It's been great to share everything with you. So that's goodbye from me.
Goodbye from me. Thanks, everybody.
Thank you, everybody.